Okay, so today I'm going to finish one more topic in the loops about nested loops, and then we're going to a new topic called two-dimensional arrays, which will be quite interesting, and then you will need that for your lab number 6. Okay, so today is highly relevant to what we're going to do later on for the last lab. Okay, so I just want to review the syntax very quickly, and then we talk about nested loop. Nested loop is a little bit tricky, but I think for the very first one, I'll go very detailed with you by drawing some flowchart to really understand exactly how that behaves. And every other nested loop we're going to see, they will be very similar. Okay. So now, I just want to draw your attention to, now we have seen many examples about for loop and while loops. So now it's really up to your judgment about how you can combine the loops together. So this so-called parallel loops, which means you try to run two loops one after the other, what we call sequential loops, doesn't matter. But you can see that in these two for loops over here, the first one and the second one, they have nothing to do with each other. So just do one after the other. But it's more often the case, you want to have nested loop, in which case you have something like this. Okay, I'm going to explain in more details to you on the iPad, but let's just go over the syntax very quickly to see how the nested loop look like. If you look at the, we call the outer loop, so the for loop over here, we have a loop counter called I, initialized to be 0 until less than a length, I++, just as we did before. But now the complication is, the body of the loop is just another loop, okay? And then for that, we call inner loop, we have another loop counter called J, and then also has a lower bound and also upper bound, and then we'll do something to it. Okay, that's kind of the syntax you want to get used to, because after this nested loop topic, we'll go into a very common application for nested loop, which is how you can process a two-dimensional array. That's something we'll focus on. But in the first half an hour or so, we're going to talk about nested loop just to get comfortable with it. Okay, so now let me just do right away some illustration for you. Okay, now I got something very similar to what I just said. Okay, let's now try to analyze this loop over here. Let's do the first one in thorough details, and others, hopefully you can just extrapolate from that. Okay, so now let's see what we are facing with. Okay, again, let me review the syntax for you. So now let me use the green color over here. So we have a for loop over here. We call it the outer loop. Okay, it's called outer loop. Okay, so it's a bit of, it's called outer loop. Okay, outer loop. And then we also got another one, let me use blue over here, which is over here, it's called the inner loop. Okay, it's called inner loop. So now, apparently the inner loop over here is part of the body for the outer loop. Let's get it straight. Okay, and then let's try to see what's going on over here. As we learned very well from before, for this outer loop, the green one over here, how many iterations are we going to run in the body? How many? Starting from 0 and then until 3. So that means we got 0, 1, 2, 3. So we got 4 iterations, right? So we got 4 iterations for the outer loop. Okay, let's put it here aside. You got 4 iterations. And to be more precisely, you got 0, 1, 2, and 3 for I. Okay, let's analyze individually first and then try to see how we can combine them together. Okay, let's see the inner loop. If you see the body of the outer loop, you can see that the first line of its body is over here, line number 2, which is simply print out the current value for I for the current iteration. And then we go on to the second part of the body of the outer loop, in which case it's just another loop. Okay, now what about this inner loop over here? Again, let's do a similar analysis. How many iterations do we have for this inner loop? We got 4, don't you agree? Right? Actually, 0, 1, 2, 3, 0, 1, 2, 3, and then 0, 1, 2. How many iterations? We got 3 iterations, right? Over here. Sorry, I was just confusing myself. Let's say for the inner loop over here, you can see that we're starting from 0 until 2. So we got 3 iterations in total. So over here, we got 3 iterations. Okay, and then 0, 1, and 2. Okay, so we got 3 iterations in total. And apparently the value over here for the blue is the value for J. Okay, now specifically I want you to pay attention to line number 4, okay, and line number 2. Okay? By the end of the illustration, which I will do, we will see that even though this line over here, which I will just highlight in blue over here, this line over here versus this line over here, the number of times we're going to execute the green and the blue are going to be different, even though they are part of the body of the outer loop, the green one. Okay? That's something, I'll just make the conclusion first. But how exactly is this going to work? Let's see, okay? So now let's try to draw the flow chart over here. Let's imagine that if you put a breakpoint over here in the beginning of this for loop over here in line number 1, the first statement that's going to be executed is going to be the initialization for I, right? So let me just start from here, okay? I'm going to use the green first. So we got integer I is assigned to 0. That's going to be the very first statement to execute, the very first one. And then after which, we're going to see if we want to execute a loop for the very first time or not. So that means the execution flow is going to make a decision depending on whether I is less than 4 or not. Okay? In the case where it is, okay, let's say true in this case. Let me put true here, and then I'll put false over here. Okay, true and false. Let me just make it more visual to you. What about I use red for false? Okay, let's worry about the true case first. Okay, in the case where it is true, that means we're going to execute line number 2, right? Now in that case, we are still not dealing with the inner loop just yet, not yet. So that means we're going to print out the value for I. Okay, let me just go back to green. So we're going to print out the value for I. Okay. Okay, so far so good? So now, after this, we're going to proceed to line number 3. For line number 3 is just another loop, so that's an inner loop. In which case, I'm going to switch the color. Let me use blue over here. And now for the blue part, we know that we have to initialize this loop counter, right? What we'll do is we'll say integer j is assigned to 0. And then, after which, we're going to actually go on to check to see if the state condition is true or not, right, to determine. And then we're going to draw that as well. Okay, let me just do that over here. Okay, j is less than 3 over here. Okay, after that, we're going to go into the, let's say, true and false again. So let's say this is going to be true, and this path is going to be false. Again, I'm going to use red for false. Okay, you know what? In case I run out of space, why don't I try to move this a little bit up, like that, okay? So now, after this, what about the true case over here? What about true? If it is true, then that means we're going to go into line number 4, right? In that case, we're going to print out the value for j. Print out the value for j. Okay, I gotta be careful. I'm almost running out of space. So now, question for you. Now, after print out the value for j, what should be the next statement to execute? Which one? You're right. We might have to go back to the start of the for loop over here since we're executing this loop. But remember, before we go back to that particular loop to actually execute the state condition again, J++, exactly. You can think about, you can imagine that the J++ is as if you put in the last line of your loop, right? Okay, good. Okay, let's try that. So that means after this, we'll get J++, like that. Okay, so now let's try to do, let's try to continue with this, okay? Now, after print out the J, after J++, we should really go back to the loop and try to check the state condition again. So that means after this, we're going to, after J++, we're going back to here and check it. Notice that I didn't draw it like this. I did not draw it like this, simply because the initialization for J happens only once. Okay, notice that. Okay, so let me just do the right way. Okay, let me just try to draw a little bit shorter over here. Okay, that's over here. J++. After that, we go here. So now, question for you. Now, apparently you can see that as long as j is less than 3 over here, we're going to keep executing the body for the inner loop, which is to print out the j. But what if the state condition over here is false? What should we do? Yeah. I++. You can think about let's think in this way. Okay, now I want you to pay attention to this particular state condition over here, this one here. As long as the yellow one is actually true, we're going to keep executing line number 4. But as soon as j is less than 3 becomes false, that means we have to go to the next line after the for loop, which is hypothetically is like this line, which is pretty much at the end of the outer loop, in which case we're going to do I++. Okay, that means we have to draw another statement over here. Okay, let me just do that, and that belongs to the outer loop. So I'm going to change the color over here. So I'm going to do like this. Okay, I++. I believe I can try to be a little bit more careful with the space. Let me just put it like this. How about that? Okay, so now I'm going to do I++ over here. Oops, too much. Okay, so now let's go for I++. I++, and then over here. Okay, now you can see that over here for false case over here, we're going to go to the increments for I++. It is when the state condition for the inner loop becomes false that we go to increment the value for the outer loop counter. Okay, and what about after I++? What do we do? Well, we just have to go back to the beginning of the outer loop over here and check it, right? Right? That's what we'll do. Over here we go back to over here and then check it. Okay, then we still go there. So now the only missing piece of the puzzle is, what if the I less than 4, the outer loop, is actually false? What if it is false? In that case, we are going to bypass the entire body of the outer loop. In that case, we should just go to over here, basically just terminates, right? So that in that case, you can just draw it like that. So you just go on to the next one. In this case, nothing, so it just terminates. Any question about what I have seen so far? Yes? Do we initialize j again? You don't. So that's what, you know what? So for the question was, after the I++ over here, do we initialize the j again? The answer is no. We only initialize j again when we go into the body of the loop for the outer loop. But you'll see that. How about it? Leave that for a moment. Okay, I'm going to trace that for you in just a moment. Okay. Okay. So now that's about it. So now let's see. Let's try to highlight the condition we want to focus on, and then we'll trace it. So we have print I over here, and also we have print j over here. Okay. So these are the two print statements we have to trace. Okay. Let's now try from the very beginning. Okay. Let's say we start from over here. Let's say we start from here. Let's say we start from the beginning over here. Okay. So now I is initially 0. Okay. So now I'm going to use a green one to put I. I is at the moment 0. Okay. I'll put 0 here. And then 0 less than 4, true. So we go this way. So we go this way. Okay. It's true. 0 less than 4. And then when we print I, we get 0. Agree? Okay. We just get 0. So this is the output, let's say. Okay, let me just try to do. So these are the outputs for us. Okay, so first of all, we get 0 over here. That's the very first output. And then after printing I, we will actually go into int j is initialized to be 0. That's the first time we actually execute the inner loop. Okay, and now j is going to be initialized as 0 over here. So I'll put 0 over here, 0. Okay, and then if we go on to see 0 less than 3, true. So that means we go for the true part, and then we'll print out the value for j, in which case 0. Okay, so I'm going to put 0 over here, 0 here. Okay, And then after that, we're going to increment the value for j, right? The next one. We're going to increment the value for j. That means it's going to go from 0 to 1. So let me just do that. So I would say it's going to go from 0 to 1 in this case. Okay? So now, after that, we're going to check. So we go back to the this loop again. We're going back to the checking the state condition again to the beginning. And now, 1 less than 3 is still true. So that means we'll still go into the true part over here. And now, j's value, we're going to print it out again, which is going to be 1. Okay, it's going to be 1 over here. Okay, it's 1. And then after printing j, we're going to execute this j++ again, which is going to increment from 1 to 2. Right? So after that, we're going to go for, let's say, 2 less than 3, which is true. That means we stay in the loop. And after that, we go for the true branch over here. We go for the true branch, and then we're going to print out the value for j, which is going to be 2. Okay? Now after this, we're going to go to the next one, which is going to increment j again, j++. Now, what's going to happen? What's going to happen is, we're going to increment from 2 to 3. In that case, when we do this checking over here, let me just use a different color this time. When we get j less than 3, we are checking 3 less than 3, which is false. So that means we don't actually print out 3. So you can see that in the output part, 0, 1, 2 is the only thing we get. Okay? So after this state condition for the inner loop becomes false, what we will do is we'll follow this branch over here, and then we'll increment the value for I. Okay, over here. So we'll increment the value for I over here. That means the i's value as we initialize, which used to be 0 over here, and we're going to increment that from 0 to 1. Okay? So that means after this, we're going to go, so 1 over here, and then we check this condition again, 1 less than 4. True, we stay in the loop. And after that, we go for true branch over here, print out the value for I. In this case, rather than printing 0 from the last iteration, over here, we're going to print out just 1. So far, so good? Hopefully you get a feel. You can see that we actually print out 3 values of j before we print out the next value for I. That's something for you to note. Okay? That's really the nature of the nested loop, which means the outer loop is going to execute, let's say this. The outer loop, let me be precise over here. The outer loop over here is going to execute exactly 4 times. So let's predict. And then also the inner loop is going to execute, let me use the blue over here, is going to execute 3 times. As we can see, 0, 1, and 2. These are the 3 iterations for the inner loop. Agree? And then for the outer loop over here, it's going to be 4 iterations. So can you predict what's going to be the final outputs from this program over here? Let's try to fit it in. I don't have to trace it up until the end for you. It's going to be very tedious, okay? But hopefully you get enough idea. And I'll make some remark in just a moment. Let's try. So now we know that we got 1 over here already. So now we can imagine that because for this particular iteration where I is equal to 1, we're going to execute this inner loop once more, which will involve 3 iterations, in which case we're going to get 0, 1, and 2, right? And then after these 3 iterations there, we go back to the beginning of the for loop, and then of course before that we also increment the value of I. Okay, so that means after that we also get I don't have space already here, and then also we get 2 over here, and then you can imagine that I also got 0, 1, and 2, and then we also get 3, and then we get 0, 1, and 2. Okay, that's going to be the final output. Okay, we got exactly this many. So now back to my original question. How many iterations do we have exactly? How many times do we execute line number 2? That's the first question. And how many times do we execute line number 4? That's the second question. The first question is much easier. You could have answered that even without studying the nested loop. Because for line number 2, it's simply part of the body of the outer loop. In which case we know we got exactly 4 iterations for the outer loop, so that means that'll be 4 times. Okay? So now what I want to note is, for this particular print statements over here, this will be executed 4 times, corresponding to exactly how many iterations we have for the outer loop. On the other hand, over here, if you look at that over here, how many times do we execute? Apparently, if you count, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got exactly 12 times. Let me just write it down, and then we try to see how can we make it general. Can we have a formula for that? So that will be executed 12 times. Can you kind of guess how did we get 12 over here? 4 times 3. What's the rationale behind that? You can thinking this way. For every iteration for the outer loop, we're going to execute the body for the inner loop 3 times, right? Now, I want to draw just one more diagram for you. It's from a slightly different perspective. Hopefully that will make sense to you. Let me just see at a page below over here. Okay, let's do one more. Okay, so now we know that the outer loop, again, we use a green one. Outer loop, we got counter I. For I over here, we have either, for I, it can be 0, it can be 1, it can be 2, it can be 3. And for every particular iteration with a specific value for I, we're going to execute this inner loop here, which will take 3 iterations. Then J is going to be 0, 1, and 2, right? So now let me just change the color, and then let's do that. So that means for this one here, and we have J, and J can be either 0, or it can be 1, or it can be 2, right? And for this one here, it's similar, 0, 1, or 2. Similarly, 0, 1, or 2. And for this one here, 0, 1, or 2. Okay? So that's how we got exactly 12 iterations, 12 times that we execute that one here. Okay? That means 12 times. Okay? So executed 12 times, so that'll be exactly 4 times 3. Okay? Okay. Over here, these 2 numbers. Any questions about this? If you got any question about the nested loop, it's now the best time to ask. Yes?
So in this example,
yeah.
we could also think of it like the local scope of each inner loop is not persisted with the scope of the...
It's a very good observation. So the observation was, we can think about the for loop, the inner for loop, starting from line number 3, is more like a localized loop over there, which means whenever you declare this loop counter over here, you can think about it. Now, I want you to also draw your attention to this. Let's say this one over here. How many times are we going to reinitialize the value for J, right? That's really a critical question to answer. In this case, it will be actually 4 times. 4 times that we reinitialize. And according to your observation, let's try to make a conclusion from that. That means values visible, let's say value of J does not persist between iterations. Does not persist. Persists between iteration of the outer loop. Between iterations of the outer loop. So every time when you try to start a new iteration for the outer loop, you got to reinitialize J, right? Okay, guys, any more questions? Now let's try to imagine something. I'm going to use basically everything you're going to see for the rest of today. We got similar structure over here. Okay, I will try to give you some more example before the final exam. So in practice, you may also see that you got 3 nested level. But this one only has 2 nested level. Let's deal with that only for now. Okay, later on I'll show you some nice application for 3 nested loops. But now for this one here, when we talk about 2-dimensional array, it's basically like it's more like a table in your Excel spreadsheet. in which case we gotta refer to row number, which is the first dimension, and also the column number, which is second dimension, in which case it's a very straightforward application for using nested loop. Yes?
What's the word between does not and between, like?
Between iterations of the outer loop.
It says does not, I couldn't understand what that word is.
Oh, does not persist. Does not persist. If I can even spell it correctly, actually. Let me see. Maybe I'm going out of boundary of my iPad. Persist. Okay. Yeah. Okay. Okay, guys. Any more questions before I move on? Yes. This one here. I would say it's covered, right? So it may be. Huh? It may be. Huh? What do you mean? What do you mean half? This is tough. That's why I'm teaching it, right? Yeah, good. Three and two. What do you mean 3 and 2? So, okay, if you only talk about lab tests, let's talk about it offline. Okay. So now, do you have any question about this program here? Which part? Maybe you have to study that a little bit further, right? Before you can ask me a question. Yeah, study that. Okay, guys, even if I don't cover that in lab test 2, I may cover that in the final exam, right? So you really want to study that, right? You have some time. You have some time. But this is a very critical pattern to learn for the nested loop. Any questions before I move on, please, before I move on? Okay, but we'll see lots of examples like this, okay? Okay, after this, so now we only got one particular example I want to show you by using nested loop. Let's try to also, again, let's try to study different versions of nested loop. Let's try, okay? Of course, I'm not going to draw the diagram anymore, but this is the kind of diagram. I wouldn't test you on that, but you really want to help yourself study. So that's kind of the diagram you want to draw by yourself. Okay, okay, I'll let you do it. If you got trouble, you can draw by my office hour. I'll show you how to draw it. Okay, now, this is a typical problem over here. Let's say we have an array of integers. We want to see if the array contains any duplicates. Okay? What I will do is I'll give you some intuition about what does it really mean programmatically when we have duplicates in the array, and then to link that to the pattern that we just saw. Okay? Basically, that's what I would do. Of course, you're going to try to fill the gap by yourself. For example, let's see over here. Let's have study 2 arrays over here. In the first array, apparently you can see that there are no duplicates, 1, 2, 3, 4. And in the second array, you can see we do have a duplicates. Okay? Let's now try to link this to the problem that we studied before. It's almost like we are trying to find out for every pair of numbers in the array, if they happen to be the same. That means we found a witness for duplicates, right? For example, let's see, let me just go to the iPad over here. So 1, 2, 3, 4, and 1, 4, 2, 4, okay? Okay, let's try to do that, okay? So now we talk about the example for duplicates. So let's say we have one array that looks like this. Let's say 0, 1, 2, 3, the indices. Let's say we got a second array over here. 0, 1, 2, and 3, okay? So 1, 2, 3, 4, the contents, 1, 4, 2, 4, I believe, right? Let me just double check. 1, 4, 2, 4, yes. Okay? Let's now talk about this particular array, okay? This one here. We know that, so the method we're talking about is, does it have the duplicate or not, right? Either true or false. So now for the second array I'm talking about over here, it should be true. True in the sense that I can indicate to you which can be a witness in the array that tell you these are the duplicates. In this case, apparently you can see that it's over here and over here. And you can see that over here, basically, let's try to be a little bit more programmatic. Let's say this is array A, okay? A is pointing to this array. We can see that A1 is not equal to A3. So this is the witness to tell us that you do have a duplicate in your array, right? Okay, that's the witness. But in general, how can we find this witness? And we want to find it in a way that's systematic. Okay? Let me just complicate the matter a little bit. Let's say for this one over here, let's say this is A2, okay? Array 2. Apparently, we know that this is going to return false over here. But how can we be so sure there is no there's no witness for the duplication? In which case, we can say we should return false. But how do we know? Unless you have a very systematic and thorough exploration of the array pairwise. Look at every two elements in the array in a systematic and thorough way. Otherwise, you can make such conclusion. You cannot. Okay? So now what we should do is we want to have a systematic way to do this, like this. Okay? Let me just draw a new page over here. Now image, page below. Okay, let's now have a look at this. Again, let me just use this array over here. Let's say A. 1, 4, 2, 4. And then 0, 1, 2, and 3. The way I'm going to do this, I'm trying to simulate what a computer would do. Okay? Basically, I want to compare only two elements at a time. Okay? So now, let's think about this. I want to compare A0 and A1. Are they equal or not? And also, I want to compare A0 and A2. And I also want to compare A0 and A3. Of course, it wouldn't hurt if I also compare A0 and A0. Let's do that. We know that itself must be equal. Right? They must be equal. Let me just put a equal sign over here. Equal, 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 equal. Right? And the check bar simply means it will be true. A0 is equal to itself. It's always true. So we got to be careful with this case. That could be misleading to our final result. Okay? Now, A0 to A1, apparently in this case, A0 to A1 is not the case. Right? A0 is 1 and A1 is 4, so it is not the case. Okay? And A0, A2, also no, it's 1 versus 2. And 1 versus 4, also not the case, right? So far, can we declare that we have found a witness yet? Even though we have a check mark over here. We cannot. Because now we talk about integers. Integers are primitive types. So for primitive types, we use equal, equal. We only use dot equals for objects. So we thinking for this, as far as this course is concerned, we most often use only the equals method on string objects. But for anything other than that, we use equal, equal, like a character, Boolean, or integer, or double. Yeah, we'll talk about equals maybe after, maybe possibly next week when we go back to the object orientation lecture. Okay. Okay. So now apparently you can see that over here. I want to draw your attention to this particular thing over here. You can see A0 is equal to itself, which will always give you true, right? So now we should not consider this. We should not consider this as a witness of duplicates. Okay? So far what we have considered is 0, 1, 0, 2, and 0, 3. Okay, let's do another one. What about, let's say, what can be other combinations we can have? Let's say we also want to do, let's say, let me just use maybe blue over here. Let's say we use index 1. A1 with A0. Okay? A1 with, basically for every index I'm talking about, I want to compare with every other index, including itself. And A1 over here, and A1, A2. And also A1, I have A3, right? That's just another comparison over here. And be careful over here because you can see that over here, A1 equals A1 is true. But again, for the same reason, don't consider. as a witness. Okay, so now, have we found any witness yet? Well, we have, right? Let's try. Let's try that. Okay, let's be careful. A1 equals A0 is false. A1 equals A2 is also false, right? 1 equals to 2. And now, A1 equals A3. Wow, it is true. So now we have found really a witness case. Okay, so this is now a witness for us. For duplicates. Okay, you can see that for every particular value, let me try to be a little bit more closer to what we said before. Remember what we said before? We got outer loop with counter I, we got inner loop for counter J, in which case we actually got all the combinations between I and J, right? With particular ranges. We got 0, 0, 0, 1, 0, 2. Also we got 1, 0, 1, 1, 1, 2, etc., right? That's exactly the pattern we can apply to this particular problem over here. So now let's try to draw a little bit closer connection over here. So now, what can be I? I is exactly over here, 0 or 1, right? What about J? J is more like the counter for the inner loop, in which case, in this case, we can say for 0, 1, 2, and 3 for the very first iteration for the outer loop. And then we got 0, 1, 2, and 3 again, right? Okay, guys, follow so far? Okay, so now we can know that, and this hasn't finished yet. After this, we can also try to do A2, and also we can have A3. Okay, so in total, how many comparisons do we have to do? In total, you can see that we got 0, 1, 2, 3. We got 4 elements. Okay, out of the 4 elements over here, we got to do 4 times 4, which is 16 comparisons. Out of which we know that things like this, like A1, oh sorry, not this. Things like A1 equals A1 and A0 equals A0, we shouldn't consider them as witnesses, right? Out of which we got 4 cases not to be considered. Okay, follow so far? Okay. Yeah. Having this in mind, so how can we write a code accordingly? What I have just explained to you was, if you want to find out if there's any duplicates over here, basically a duplicate simply means you have 2. Let me just use highlight over here. Duplicate simply means you have 2 elements in your array, and the indices for them are not equal, and their values are the same. Okay, that's what it means to be a duplicate. Okay, let me write it down. And then we'll see how exactly you can write this. And I'll show you different versions very quickly. So duplicates. Duplicates means AI equals AJ. And not only that, ampersand, I is not equal to J. This is really important, because for cases like this, we don't want to consider them. Okay, so these are the 2 conditions for having a duplicates in your array. Okay, okay, let's have a look at how the code would look like. Okay, let's go over the first version now. Okay, but this first version over here is going to go over basically every pair of indices, 0, 0, 1, 2, 3. Okay, I'll show you the diagram in just a moment. Okay, so now let's just go over the code. Okay, over here. So we declare a Boolean variable over here has duplicates, initially false, because initially we haven't found any witness just yet, so that's why it's false. And then we initialize I to be 0 less than a.length. You know what, let me to be consistent with my color from before. What about green over here? So I would be the counter for the outer loop. And similarly, we also got J to be the counter for the inner loop. Okay, and now that means this line over here, okay, line number 4. Line number 4 will be executed for, how many times do we have? If you only look at a code like this, can you express a formula for me, some expression? How many times? Eta length? Exactly. Very good. Thank you. For eta length, which will be the number of iterations for the outer loop, out of which, for each one of them, you're going to execute the inner loop, which will take also eta length iterations. Okay. Okay. That means we're going to compare. And every time, and we're basically just doing some accumulation, like what we did before. We want to make sure I is not equal to j, the current pair that we're comparing, and then also ai is equal to aj. As soon as we find out this condition over here is actually true. So this condition over here is exactly what I said over here for duplicates, exactly. Okay? Once we found it out, we're going to accumulate that condition to has duplicates using disjunction. Okay? It's or. Either this pair has a duplicate or that pair has a duplicate, and etc. Right? As soon as we find out one, which will make this condition over here true, and that's going to accumulate true throughout. Right? Any question about this? Yes. Oh, this one here? Sure, no problem. The question was, can I explain this again? Okay, to really understand why this is the case, right? Because in the case of two-dimensional array, you got a slightly different case. But let's say for this one, okay, I want you to look at the upper bound for the loop counter in both cases. In the case of the outer loop, let me use green. We got I is less than eta length, right? That means over here, let me try to be precise over here. That means for I, it's going to be 0. I is going, let me just be consistent with color. Let's say green. Okay, I is going to be 0, 1, all the way to eta length minus 1, right? So what about the blue part for the inner loop? For the inner loop over there, let's try to highlight that. It has the same upper bound. Okay, that means for every value of I, we're going to run the inner loop for exactly that many times, right? The body of the inner loop, right? So now let me just do one of them. So for I particular, we have j, which is going to be 0, 1, all the way to eta length minus 1. So now you tell me how many times we're going to execute line number 4. In which case you can see that it's simply for when this case we're going to execute the first time. And for this case, execute the second time. How many times in total? It's going to be the size of this particular tree over here, which will be eta length. And then, how many such branches do we have? We got 0, 1, 2, 3. We got eta length as well. So that's eta length squared. Okay? Yes? So your question was, let me make sure I understand you correctly. You're asking, what if we change the disjunction to conjunction? The question was hypothetically, let's say we change this to be true. And then we change this to be ampersand, ampersand. Okay? So now, I would say I like the way you want to change it because you don't just change arbitrarily. Basically, just changing this to another problem over there. What you're trying to do over here is you want to make sure the array has basically every element to be the same. Okay? Why? Let's just see one example. I think it's a very good question. Guys, it's a very good question we have here. The question was, given a code like this, what if we change false into true? And then we also change from disjunction to conjunction. So basically, let's say before the change, what does it really mean? We want to know if there exists at least one pair of indices that will be duplicates. So now we want to know after the change with true and ampersand, we want to make sure every pair, all the pairs of indices in the array are duplicated. Okay? So now let's see one example. So now let's see over here. You know, I really want to do this properly. So now how about this? let's say we got array A over here, and then 0, let's say we simply got, let's say 1, 4, 2, 4. Okay, like that. So now, before the change, that means we still have false, and also we have disjunction. In which case, we want to make sure there's at least one that will actually give us the duplicates. In which case, before the change, that would just be true. Because A1, so 0, 1, 2, and 3, because A1 is equal to A3. Okay, what about after the change? After the change, as I said, what it's going to check will be, it's going to check for every combination of the I and j, the corresponding elements must be the same. But that's not the case, right? So that will be false. But we want to see why. False. And if it is false, we want to find out what's the violation witness, as we said before. In this case, because, for example, when you run A0 and A1 is false. Right? Okay, guys, do study this kind of particular change. I didn't expect this, but that's a very good question. Okay. Okay, any questions about this example here before I go on to go over more versions? Yeah.
Is this considered an efficient algorithm?
Good question. The question was, is this considered as an efficient algorithm? I would say, informally speaking, it is not. Informally speaking, that's why I got different versions to show you. Apparently, let me just go a little bit over this, okay? I do want to cover this properly. Let's have a look at this, okay? If you try to look at that, this is basically the trace for array. Okay, let me just also refer you to the slides quickly, and then I'll cover that together, okay? Okay, that's a code you have, okay, over here. Okay, I believe that's what I have over here. Let me just make sure I do the right one. Okay, good. So the array, let me just write something on the iPad and then I'll switch. So the array I'm considering is basically, let's say, 1, 2, and 3, okay, over here, like that. Let's say the array I'm trying to consider would be, let's say we got an array of size 3, okay? That's why we got 9 iterations, 3 times 3, right? According to our formula. Now back to your original question. Is this really the most efficient way that we can define for the loop? Being efficient means, is this the minimum number of iterations we can have in order to get the answer? I can tell you that no. Because, for example, let's say after the first iteration for the outer loop, let's try together. After the first iteration, we have already considered 0, 0, 0, 1, and 0, 2. Now, when we go to the second iteration for the outer loop, we got I being 1 over there, right? So now, are we repeating some checks over here? We are, because let me just outline for you. Over here, we do have, let's say, 0, 1, and 1, 0. We already checked for 0, 1 previously. Why are we checking 1, 0 again? Right? That's kind of drawback. So it's not really that efficient because we have more iterations than necessary to get the answer. Because whatever you get from this iteration over here should have been included in this result already. There's no point to do it one more time. Okay? So this is redundant. Let me just point this out. And then I will just go a little bit further. Redundant. But now, I want to just talk very briefly about efficiency. So for those of you who might take 2030 with me again in the fall, so maybe you can bring this example back to me again. We can explain once more. Okay? What I would say is, when we talk about efficiency, it does have a formal meaning about what you really mean by efficiency. So there's some mathematical function we can associate it with the loop over here. I can tell you that mathematically speaking, remember we got a.length multiplied by a.length. That's what we had before. Okay? In general, if you think about the size of your array is n, and the size of the array is just n. So we say that the complexity for your loop is n squared. Okay? If and if we can get rid of the redundancy over here, the complexity is still n squared. That's what I can tell you. Okay? But you don't have to worry about this part just yet. This is something that we have to introduce to you. It's something called computational complexity in 2030. Okay? But for this course, you just have to know that from version number 1 over here, you do have some redundant scans like this. Okay? So now how can we improve this? Okay? So that's why we got further versions for you. Okay? So now the further version I want to show you is basically like here. I want to show you over here this version here. By the way, for version 2, without a redundant scan is version 3. Let's say for version 2. Okay, version 2 over here. Okay, we still have redundant scan. We still have it. There's one change I made. Okay, there's one change, which is better. You can see that over here, we still have this condition over here. Agree? Over here. But now there's something extra I added. Notice what I added over here. I added to the state condition over here, has duplicates and has duplicates over here. So what does that mean? That means in order for you to keep iterating, you must make sure we have not found a duplicates. Okay? I'll give you one example. Let's say this. Let's say again, 1, 4, 2, 4. Let's try this one here, okay? And then we also got 0, 1, 2, 3. So now let's try to be a little bit concise over here. So we got I and j, and also ai is equal to aj. Okay, like that. Okay, so now we have 0, 0, 0, 1, and 0, 2, and 0, 3. Okay, that's what we had before, right? So now 0, 0 will just be true, but in which case we ignore. Okay, somehow you can check the code. And then 0, 1, 0, 1 is actually false. 0, 2 also false. 0, 3 also false. So far we haven't found anything just yet, so far. Okay, so has duplicates up to now is just true. Okay, up to now. That's for the very first iteration for the outer loop over here. Okay, so now let's go to the second one and then I'll show you. So now let's say we also got 1, 0, 1, 1, 1, 2, and 1, 3. Let me try to see if I can make some space for myself. Give me one moment. Okay, good. Okay, so let's say we got 1, 0, 1, 1, 1, 2, and 1, 3. Let's see what's going on here. In the case of 1, 0, it will still be false, right? 1, 0 is, they're not equal. 1, 1 is equal, but we're going to ignore that. Okay, what about 1, 2? In this case, it's actually false. But now for 1, 3, in which case we have found a duplicate witness. In that case, I would say true over here. So what's going to happen here? As soon as this expression over here, so for this particular combination, I being 1 and j being 3, I being 1 and j being 3, and 1 and 3. Let's see what's going to happen over here. So 1 is not equal to 3, correct. And now what about a1 over here is equal to a3, 4 is equal to 4, yes. So that means this is going to be true. So now let's see what's going to happen over here. If as soon as after the execution for the body of the inner loop, we're going to go back to the beginning of the for loop over here in line number 5, in which case you can see part of the state condition is not the case we have found a duplicates, right? Duplicate has just been assigned to true. Not true will be false. That means this is going to be false. What does that mean? That means we don't continue with this inner loop anymore. We just pause from there. And then after that, we are going to also go back to the beginning of the outer loop. In this case, we also get, as part of the state condition over here, we have not found a duplicate, in which case we have found it. So that means not true will be false. That means we also bypass everything else. So by having this not has duplicates over here as part of the state condition, we can achieve some efficiency a little bit. We can minimize some redundant scan, which means as soon as we have found the duplicates, we exit from the loop. Yes.
How does a reductant scan like work on like your Android Studio? Because here like you don't really get like what is meant by a reductant scan when it's run on Android.
Yeah. So over here, you can think about the way we are studying the code. We are more like a debugger. We are trying to go very slow motion, step over line by line. When you do this on Android Studio or when you run your app, you don't see this actually, right? So now just imagine this. Maybe somehow if you have a very large array with 1 million elements inside, then going from one version to another with the redundant scans eliminated, it might make a difference when you see your app. Your app might be more responsive than the other version. But I would say for this one, we just try to study the behavior of the code. They will, between versions that I'm trying to present to you here, they achieve the same thing. But it's just that one is being a little more efficient than the other, or quote, efficient, right? Okay, so that's about version 2. Version 2, the trick is we added something in the exit condition, the state condition. Yes? Which one? 0, 1? Which one are you talking about? You mean over here? Oh, you mean this one? Has dupe. Sorry, which line are you talking about? Over here? Oh, you mean over here? Okay. This is because, yes, you're right. That should remain false. Thank you. Yes. Yes. Good. Very good. So guys, sorry, this is a typo. Maybe I thought about true in my mind, but I actually wrote true. It should be false. Yes. Because we initialized the false has duplicate to be false. Okay. That should remain false. Okay. And now you can see that as soon as we reach this particular combination, it becomes true. Okay. Good. Very good. Guys, any more questions before I move on to another version? Okay, I know the example is tricky, but that's why I show you here. Okay, okay, let's try to challenge ourselves even more. So now we want to go to the next version over there to get rid of the redundant scan. You can see that we got 0, 1 and 1, 0. In the second version there, we still got 0, 1 and 1, 0. The redundant scan was still there. We haven't gotten rid of it in the version 2. Okay, redundant scan, still there. Okay, so how can we get rid of this? The intuition is basically, let's thinking this way. So now, if I'm currently running the iteration for I being 1, I'm pretty sure for all the value that's smaller than 1, they have been checked already, basically, because we have exhaustively checked for the value for 0 over here. Okay, that's kind of the intuition. But how do we see that in the code? Let's try to see that. Okay, so basically for this code over here, it's pretty much the same as before, except for this particular one over here. Let's try to see why this can do the trick. Let's try. Let's not worry about how the has duplicate is going to change. It changes. It's going to change just like before. But now we want to see exactly how this line over here is going to affect the combinations of I and j that we're going to run. Okay, let's see that. Okay. So now rather than initializing j to be 0 in version 2, in version 3, we say that it should be exactly to the value of the current value of I plus 1. Okay. So what does that mean? Okay, let's try to see that. Okay. Okay, so now let's try that. So when I is equal to 0, let's say I and j, let's try that. Okay, when I is equal to 0 over here, okay, so what will be the first value for j that we run? Would it be 0? No, it now should be 0 plus 1, that should be 1, and then it will be, oh, which array I'm talking about, right? Let's say we talk about this array. Sorry, forgot about that. So let's say we got 1, 4, 2, 4. Okay, so 0, 1, 2, 3. Let's say these are the indices. So now we know that j is going to be initialized to be I plus 1. So that'd be 1, and then 2, and then 3. Right? So we got 0 and 0. So that's the very first iteration for the outer loop. And then we increment the I over here, and then I will be 1. So now for this particular value over here, what will be the first value for j? 2, right? So that will be 2 and then 3. Okay, and then we go to the third iteration for the outer loop, which will be 2, in which case we just get 3. Okay, and then what about, do we have a fourth iteration? We do, but in which case we only get 3 over here, but you can see that 3 plus 1 will give you 4. That already exceeds the bound, okay? So that's about it. So these are all the indices we'll check in this particular version. So let's think about what's really rationale behind, okay? You can see what's really missing over here. You can see that over here, we got 0, 1, 0, 2, 0, 3. We don't have 0, 0 because we know that it's a don't care condition, right? Because A0 and 0, we don't really compare one element to itself. So now, what's really missing over here? Missing from versions 1 and 2, in which case it's redundant, right? So what's really missing there? We were missing 1, 0, and 1, 1, right? Now, 1, 0 over here is already covered. Why? Because you can see over here, 1, 0 is already covered in the case of 0, 1, right? It's already covered. So we don't have to check it again. We don't have to. It's pretty much like what I highlighted before over here. 1, 0, and 1, 0, and 0, 1. Okay? So now, what about the case for 1, 1? Also, we don't care, right? Because it's really equal to itself. So it's also okay to miss it. This is don't care. Okay, so okay to miss these. Okay, so basically in the version number 3, we're trying to do 2 tricks over here. Trick number 1, we're trying to say as soon as we have found the duplicates, it's going to make the state condition for the outer loop and inner loop false. So we exit right away. On the other hand, we also try to play with the initial value for the inner loop counter, in which case we try to not to redundantly scan through the array. Okay? So these are the 2 tricks. I want you to also try to convince yourself by running the example in more details. Yeah? If you got trouble, let me know. I'll try to run over again with you. Any more questions before I go on to 2-dimensional array? Are we okay? Yes. The proof? Yeah, I can show you something on the slides actually. Yeah, let's see some slides. Yeah, I haven't really gone back to the slides for a long time. Okay, that's a version 1 with redundant scan. So now, for version number 1, in the case where we have no duplicates, and also in the case where we do have duplicates, we have to run exactly the same number of comparisons, no matter what. That's why it's redundant for version 1. When we get to version 2, where we added the state condition over here, in the case where there is no duplicates, we still have to look through everything, every combination, to say that there's no such violation witness you can find. However, for version number 2, in the case where you do have a violation witness for duplicates, in that case, you only have to run this many iterations, because as soon as you have found the duplicates over here, let's say 4, 2, 4, so that means 0 and 2, right? As soon as you find it out, you will set the has duplicate to be true. In that case, you will make the state condition to be false. So you're going to exit from the loop. Okay, that's version number 2. Now, if you go to version number 3, in that case, we just do a little bit more extra trick. We try to play with the initial value for the inner loop counter j to be I plus 1. So now, in the case of we have no duplicates. Let's try to only focus on the value for I and j. We got 0, 1, 0, 2, 0, 3. We don't have 0, 0, right? And now for the second iteration for the outer loop where I is equal to 1. In this case, we missed the combination of 1, 0 and 1, 1. As I explained before, missing these two, 1, 0 and 1, 1 over here is okay because they either have been scanned or we don't care. Okay, it's okay to miss them. Okay, now, and of course I can just go on. Now, in the case of we do have a duplicate and we have no redundant scan, you can see that we combine everything together. Okay, I'll let you trace that program specifically. But if you really want a mathematical proof to say version 1 in terms of behavior is really the same as version 2, is also equal to version 3, let's not worry about that. The last one? Because you can see that we got 2 repeating twice, right? Over there. So A1 and A3 are the duplication case, right? Yeah. So guys, I would suggest follow these examples carefully. We got many versions there for you to study. Okay? So make sure you understand these. Otherwise, it'll be difficult for you to do left 6. Okay? Okay, so let me see anything more. Okay, I think that's about it for the loops lecture. I'll continue from here maybe next time, but I want to do two-dimensional array. Yes. Yeah. AI equals A. You are A2. I see. You're right. Thank you. Very good. So very nice. I'll change this. So guys, there's a typo there in case you're watching the recording. So basically over here, A1 and in the last row, A1 equals A3 should be true. Okay, good, very good, nice. I like that. Good. Okay, I'll fix that. Good. Okay, so now let's talk about two-dimensional array. You will see that the way you walk through the two-dimensional array is very similar. Now we just change I to be row and J to be column. Okay. Let's just go there and see some motivation problems, some interesting problem to solve. Okay, and then we'll go through some examples, many examples together. First of all, let's think about, you don't know about two-dimensional array. For those of you who know about two-dimensional, pretend you didn't know it. Okay, how would you solve this problem over here? Okay, let's think about the problem over here together. So now, I want you to consider a table like this. The numbers may not be 100% authentic, but you will get an idea. Okay? So now, let me just go through the table with you very quickly. Basically, it's a distance table. You can see that, for example, let's say if you want to say, I want to go from Chicago to itself, 0. You don't have to go there, you're already there, right? On the other hand, if I want to go from dollars to Atlanta, you will just find out the corresponding entry is over here, right? Basically, by the way, there's some convention over here I wish we can agree. Over here, when we talk about things go vertically, we call them row. And things that go a little bit horizontally over here is column. Column, right? Okay? So now, I would say this is row number 1. Well, I should really say row number 0 to begin with, because array always starts from 0. So this is row number, okay, let me just try to do this one. Okay, let's agree on this. Okay, we got row number 0, row number 1, row number 2, etc. And also we have column number 0, column number 1, and column number 2, etc. Okay, so now whenever we want to get access to some data, we want to say, how do I get to this particular data? Okay, this data is basically the intersection of row number 1 and column number 1. Okay, intuitively, right? Oh, sorry about that. Let me just put it there. How about that? Okay, this dot over here is the intersection of row number 1 and also column number 1, okay, on a diagram. And how do we find out the distance between dollars and Atlanta? How do we do that? We go to the row for dollars over here, and then find out the intersection with the column Atlanta. That's how we find out this entry over here. Okay? So far, so good. Okay, let's see what problem we want to solve, given that we understand how to look up information from the distance table. So now, let's say we want to support the calculation of mileage for some frequent flyer for some airline. So let's say this. Let's say we have an itinerary for your trip, which is going to be an array or sequence of cities. Let's assume all the cities are available, are really there in the table. Okay? Let's say this is my particular itinerary. I want to go from Boston to Chicago, and then go to Miami, and then go to Houston. If I want to buy this particular tickets for this itinerary, how many distance, what will be the distance I will be traveling, right? How do we look up the table accordingly and calculate it? Okay, that's a question. So before I do that on the diagram to show you, let me just do something on the iPad very quickly. So we got Boston, we got Chicago, and we got Miami and Houston. And then I'll show you on Android Studio as well. Okay, let's say this is my itinerary. Okay, it's an array of, or a sequence of cities. Starting with Boston, go to Chicago, and go to Miami, and go to Houston. Okay, let's see how we can calculate this. Now, let's imagine, also think about how you would do this in Java. Okay, that's what we're going to do eventually. Okay, but now pretend that you don't know about two-dimensional array. Okay, before I get to the implementation part, let's see how we can use this table here to do the calculation. Now, first of all, how do I go from, let me use this color here. How do I go from Boston to Chicago? From, let's say, row number being the source and column number being the destination. Boston to Chicago. Okay, I get this. Okay, that's the first part. Okay, how do I go from, let's say, Chicago to Miami? I want to go from Chicago over here to Miami. Okay, I will get this. Okay, that's the second part, right? And how do I go from Miami to Houston? Okay, in that case, I'll go from Miami over here to Houston, which would be this number here. So in total, it's going to be like this. We know that from Boston to Chicago, it's going to be 983. Chicago to Miami is going to be 1,375. From Miami to Houston, it's going to be 1,187. Okay, add them up, and then that's how you calculate the mileage for your itinerary. Okay, any question about looking up the table and to solve conceptually this problem over here? Given a sequence of cities as your itinerary, we want to calculate the distances that will travel accordingly. Okay? Okay, good. Now, I want to show you very quickly a demo without showing you the Java code, because I do want to talk about how you will implement this without two-dimensional array. It's possible, but it will be ugly. Okay? You want to learn about not just the good solution, but also the best solution. Okay? So let me just go to the, I'll also make the source code available to you tonight. Okay? So now let's say I got version 1 and version 2. Basically, version 1, for calculate mileages of itinerary, version 1 is without the use of two-dimensional array. Version 2 is with the use of two-dimensional array. Let's do version 1 first. Okay? I'm going to run it and show you how the program is going to behave. And then we'll talk about it. Okay? So let's do exactly this example over here. How many cities do we have? We got 4 cities. Okay? 4 cities. So we're going to enter all the cities one by one. Okay, let's say I want to do Boston, Chicago, Miami, and Houston. Make sure you type correctly. So Boston. Okay, second one, Chicago. And then also Miami. Okay, Houston. Okay, after that, what you would do is the output from the program. You can think about how you would do this before you look at my solution. You can think about it. So now, from Boston to Chicago, we got exactly 983, which is what we got over here, right? And also, as part of the output, you also got from point to point, and then the sum up all the distances together. Okay, that's how the program is going to behave. But now, let's talk about how you would do this without two-dimensional array, with what you have known so far, using y-dimensional array, just a sequence of arrays. Oh, sorry, sequence of elements. Okay, so now the critical thing to implement is basically this table over here. Okay, for lab number 6, it's going to be a different flavor of the table, which I'll briefly talk about at the end of today. But now, let's think about for this particular table over here, if you can only use one-dimensional array, what would be the naive solution to do? How many arrays do we need? 7, right? One array over here, one array over here, one array over here, one array, one array, one array, one array. We got 7 arrays. However, the really ugly thing is really about how we can determine the distance between two cities. Let's see how that's going to happen. Okay, let's go over some source code over here. Okay, let's do that together. And this is somehow related to what we talked about last time, the 4 versions of example. They're very similar. Okay, just go a little bit further. Okay, let's go together. So now, first of all, we have line number 1 just declares an input for reading user's input string, how many cities, and then you just see how many, and how many is actually used to create an array. Okay, over here. So, for example, if you actually enter, let's say 4 cities, you can imagine that we're going to create an array of 4 cities over here, and then it's going to be trip. Okay, you can see the name of the array is trip. And then from what we just did, we got Boston, Chicago, Miami, and Houston, right? So basically, the first one is going to be Boston, Chicago, Miami, Miami, and also we got Houston. Okay, so these are the 4 cities. So that's what you have. However, how do we go from there? So this loop here is very easy. We have covered that already. But now, how do we declare those arrays? How do we do that? Let's just go over some. Let me see if I included that in the slides. Let me just see that quickly. Okay, first of all, we can simply define some constant over here. You can see that, I'll give you some preview. This is how we're going to do. Basically, we're going to have different arrays. Array number 1 over here, array number 2, array number 3, and etc. 7 arrays in total. But in order for me to look up, for example, 1375, the information over here, I want to know what's the corresponding integer index for the city. For example, for Miami, the index should be 0, 1, 2, 3, and 4. And the index for Chicago would just be 0, right? Etc. Okay? To make it more readable for your code, what I would do is I'll just define some constant as shown in the slides. I'll say Chicago, Boston, Miami. So these are the relevant ones for the example. But in the code, what you will see is like this. What you will see is exactly the constant like this. Okay? We simply got Chicago, Boston, New York, Atlanta, etc. 7 different indices, starting from 0 until 6. Okay? Now, apart from that, this is what we got to do. Okay? So you can see that I'm defining 7 different arrays over here, right? Each one of them, for example, the first array is called from Chicago. That means it's going to be the distance specific to the departure city being Chicago. Okay? So this will correspond to exactly the first row over here. The first row over here. Just the first row. Okay? Okay? Similarly, you also got from Boston, from New York, from Atlanta, etc. Okay? Given that we got 7 constants, we also have 7 arrays. That's the declarations. Any questions until now? If that's not straightforward to you. Okay? So far, not too bad. If you use 2-dimensional array, you cannot get away from defining similar stuff. But what's really going to be a mess will be as follows. Okay, let's go back to the code. So now let's go back to the code over here. Okay, so now let's say this. Let's say once we read from the user, let's say the user said, I want to go from Boston to Chicago, Chicago to Miami, Miami to Houston. Now we want to calculate, for example, we want to write in write out a loop, for loop, to say go from the for loop, maybe from from 0 to, let's say 0, 1, 2, 3, right? From 0, 1, and 2. And then when I'm in 0 over here, I want to see what's the distance between these two, right? What's the distance between Boston and Chicago? And when I is equal to 1, I want to see what's the distance between Chicago and Miami. When I is equal to 2, I want to see what's the distance between Miami and Houston, right? Intuitively. But how easy would it be for us to know this? Because you have, for this one, I just give you a particular example. In general, you have no idea how many cities there are, and also what exactly the user has entered. There could be 10 cities, or there could be 5, or could be 15, right? So now, let's just go over the line over here, and then I will ask you to predict what's going to happen. Let's try. So now we got destination index over here, okay, and also, so it's exactly what I said before. I will go for how many minus 1, because I will simply go for 0, 1, and 2. I don't have to go for 3, because 3 will be the final destination, in which case we don't go from Houston to Houston, right? So that's why it's how many minus 1 over here. Be careful. Okay, and then for every iteration there, we're gonna calculate, we're gonna see what's the source, the departure city, and what's the destination city. In the very first iteration, I'll give you one example. When I is equal to 0, in that case, source would be trip at position 0, in which case it will be Boston. Okay, source is a string. And also for destination, it's going to be trip at position I plus 1, which will be 1, in which case it's going to be Chicago. Okay, like that. In that case, of course, what I should do is, if I know these already, what should I do? Remember, we got the array over here, so which array should I get access to? From Boston or from Chicago? Well, actually, it doesn't matter, right? But I would say let's follow a systematic manner. From Boston, right? Okay, good. So you can see we want to go from Boston to Chicago. In this case, what you should do is you want to go for this array over here from Chicago. Okay, so let me just write it down here. And then we want to generalize that from Chicago over here, and then now, oh, sorry, from Boston. Sorry about that. From Boston. Now, if I pass Chicago here, does it make sense? Would it even compile? It wouldn't, right? Yeah, you're expecting some integer expression for index, so this is not good. So what you should do is, before you can, well, first of all, we want to know which array to get access into. Depending on the value, the string value of the source over here, determine which array. Whenever I say determine, that means not if then else. Now, I cannot pass Chicago directly, which is a destination value. That means, depending on the value for the destination city, I want to figure out what's the corresponding index into the array, right? So now over here, so there are two decisions over here. Depending on the value of destination, figure out index. So there's no way you can read it, right? Yeah, but you can just listen to the recording. Hopefully you will figure out. Okay? So there are two decisions we have to make. First of all, Boston is going to tell us we should really go to the from Boston array. Chicago over here tells us we should go to this particular index over here. So from Boston and Chicago, that should be index 0. Okay? So how can we make these decisions, right? That's the tricky thing. So now, line number 15 is my question for you. How do we actually figure out this? What should you write? Apparently, you got two decisions to make. Would it be enough you just do if, else if? Would it be enough? Or should you do something that's way more complicated than that? That's my question for you. And think about this. We are trying to solve a problem that can be applied to other contexts as well. So in general, if the number of cities we have, rather than 7 by 7 table, it can be 50 by 50. It can be 100 by 100, or 100 by 150, right? Things like that. We want to be as general as possible. But now just focus on this problem here. We got source, we got destination. What should we do? Yes, correct. Yeah, so basically what we have noticed is, in order for you to really figure out the distance between source and destination, first of all, let's figure out which array should we go into, right? For example, let's say this. I'll sketch some code for you, and then the next slide I'll show you the complete code. So we'll say something like if source dot equals, so this is the case you got to use dot equals. Equals, let's say Boston over here. So now, if we know that this is true, then that means we got to use the from Boston array, right? But more than that, depending on what the destination index is, in that case, we have to actually use something specific, right? So let's try to do a little bit more. Under the circumstance where it is Boston, if the destination is dot equals, let's say, in this case, Chicago. Let me just say Chicago over here. Okay, if this is the case, so now I can do something over here. Right, in that case, I can definitely do from Boston. And this is where the final variable can be useful. Remember, we defined a constant before. Remember, we got Chicago over here, right? So that's the index where it can be useful. Okay, so I'll just put it here. So I'll put Chicago here. Okay, you can see decision number 1, what a source is. Decision number 2, what a destination is. Decision number 1 is going to make us choose the array to get access into. Decision number 2 is going to tell us where into that particular array we just have chosen to go into. So now this is only one case. How many cases do we have? 49. How did you know that? 7 times 7, depending on how many cells you have already, right? What if we got 10 cities? 100. We got 12 cities, 144, right? Etc. Okay, let's make it more concrete for you. If you look at the slides over here, let me show the slides first. How about that? Okay, that's going to be something like this. You got to say if the source is basically source can be Chicago and the source can be Boston and etc. So it's outer if, right? And then under each particular branch of the source, you can have the destination can be Boston and the destination can be New York and etc. That's why you got 7 times 7. Okay. Okay. So this is definitely not the way to go. Okay. So now, what can be a good solution to this problem over here? 2-dimensional array. Because the way you make the decision over here to really go to a particular array, to go to a particular row, this can be eliminated in the 2-dimensional array. That's something we have to learn. Okay? Any question about this example so far? We only talk about a particular solution over here. It's a bad solution. It works, but it's not good. It definitely doesn't scale, especially when you have a very large number of cities to support. So which means for any realistic application, this solution is not going to work very well. Okay, if no questions there, let's now try to go to our 2-dimensional array. Okay, let's just go over some basics. Okay, let's see what. Okay, good. Okay, so before I show you the exact syntax for 2-dimensional array, let's see how we can use it. Okay. Okay, we have gone through this already. Okay, that's also gone through already. Okay, drawback, you got this many possibilities to program explicitly. Okay. Okay, let's go over some 2-dimensional array idea. The idea is very simple. The way I think about it is, it's simply an array of arrays. Let's see how. Okay, let me show you some syntax over here. Let's say we got a matrix over here. When you say, let me just 5 by 5, okay? Let me just add a new page over there. Okay, so now let's review what we said before. One-dimensional array. One-dimensional array. Let's review what we did before. If you say integer square brackets array is new, let's say A. Let me just say 3 over here. Okay, just make it a little bit smaller. So what this will do is, A is going to store the address of some one-dimensional array of size 3 with indices 0, 1, and 2. And initially, all the values will be the default value for integer 0, 0, and 0. Okay, that's one-dimensional. Okay, quick review. Of course, you can also do something like this. You can also do integer array. Let me just use the same color over here. You can also do something similar here. Integer array, also one-dimensional A2. Let me say A1 here, A1. A2 is, you can use the initializer expression over here. You can say maybe 2, 4, and 6. What this will do is, you can say A2 pointing to an array of size 3. 0, 1, and 2. And then we got over here 2, 4, and 6. Right? Okay, so now, what about two-dimensional array? The way I draw it will be a little bit different, okay, but very similar. Okay, let's try that. Two-dimensional array. Okay, the way you refer to one-dimensional array is by the index. So when I say the index, it's quite obvious. You only got one kind of index, right? But in the case of the two-dimensional array, you got two kinds of indices. In which case, you got to tell me which index you're talking about. Okay? So now let's try this. If I say integer array, so now for the two-dimensional case, just add another pair of square brackets. Okay? And then let's say A3. And then I would say new over here. Okay? Now, here comes the interesting bit. Over there, you can think about this 3 over here is the size, right? For the entire array. But now, since you got two dimensions, you can specify the sizes for both dimensions in the following order. If I say new, let's say integer array, let me say 3 and 4. What about that? Okay, let's try to understand this correctly. So the 3 over here, is the number of rows. Okay, and also we have the 4 over here is a number of columns. Okay? Huh? So the A1 and A2 they're here. I haven't drawn the A3 yet. Oh, I see what you mean. Thank you. Good. Guys, hopefully you saw that, right? Yeah, good. Okay. If you can see that it's kind of easy to get a mistake, but make sure you don't make that mistake in lab test 2. Okay? Good. Okay. Very good. Okay, that should be a type, yes. Okay, so let's try this. So now, number of rows and number of columns. Let me try to draw in this way. Conceptually, let's try to draw two versions. Conceptually, how does it look like? Okay, let's try this. Conceptually, you have a 3 by 4. So, okay, like a 3 by 4. So you have over here 3 rows, and then over here you have 4 columns. Okay. For example, how do I refer to this particular element over here? for example, over here. Let's say this one here. How do I do that? Okay, so this is going to be intersection of row. So for row, I'm going to say 0, 1, and 2. Row 1 and column, also starting from 0, 1, 2, and 3, and column 1. Okay, row 1 and column 1. Okay, that's conceptually how you can refer to it. And I might just draw like that, later on. But now I want to give you some idea about how it would look like more closer to your memory. It's going to be an array of arrays. So it looks like this. Programmatically speaking, it looks like this. Let me do this. Programmatically, it's going to be an array of array. Remember, this size over here, 3, tells us how many rows we have. So now, let's say A3 is going to point to, first of all, an array. Now, since we are trying to talk about two-dimensional array, let me draw that vertically rather than horizontally, like that. Okay? 0, 1, and 2. 0, 1, and 2. Consistent so far. Okay? Now, how do I deal with this over here? Apparently, A3 itself is referring to an array where each element is just another array. Okay, let me write it down. Points to an array of 3 elements, each of which being an array of 4 elements. How do we draw that? Let's try to draw that together. And each element for that array is just an integer. Let's try that. So now for A, like that, an array of, so you can see that okay, I'll get there in just a moment. Okay, you can see that 0, 1, 2, and 3. Okay, similarly, so the second element over here is also an array of 4 elements, 0, 1, 2, and 3. And this one also similarly is also this one here. Okay, 0, 1, 2, and 3. Okay? Now, how do I refer to the same spot that I talk about conceptually? Right? Basically, it's like this. I want to, first of all, you can see that I really want to go to this particular slot, basically. But how do I get there? I want to, first of all, tell me which slot I should go into for A3. A3 is pointing to this array over here. I want to go to this particular slot, which points to this particular array. And then for that particular array, I want to go to slot number 1, index 1. But how do I write it down? Okay, let's try that. For that one there, I'm going to write this. Let me use pink over here. So when I say A3 is an array of array. You know what? Let me see if I can do it. Let me try this. Can I just copy this? Let me try. Okay, add page below. Good. I can even make it larger if I want to. Resize, like that. Okay, so now how do we get access to this array over here? Let's try. Let's talk about different levels of accessing. Okay, let's try. First of all, let's try first level here. If you say A3, A3 is talking about an array of arrays of integer. Okay? Now, what about A0? This is also valid. If I say, A30, yeah? A3, 0. What's A3, 0? A3 is pointing to this particular array over here, A3. Now I'm talking about this particular slot. What about I say 1? Just to be consistent with what I said over there. What about 1? Okay, so A3, 1 is talking about this particular slot, which points to this array over here, right? This array here. Okay, it's basically an array of integers. Okay, just array of integers. Now, from this array particularly, how can I get to its element over here? This is why you do it. A3, go to first array, which is here, and then go to the first slot, 1. So this is an integer. Just add another extra brackets. So now, for your information, for Java as a general purpose programming language, you can have as many dimensions as you like. So we are only showing you 2-dimensional array. There is no constraint whatsoever to stop you from writing this. You may write something like this. You may say integer 1, 2, 3, 4, as many as you like. Okay, and then I have some array over here is assigned to new, and then integer. Of course, I can say maybe size 2 by 3 by 4, all the way to maybe 10. Okay, you can definitely write something like this, but is that really what you want? It's up to your judgment. I would say typically you don't go beyond 3-dimensional, typically. I would say 2-dimensional is good enough for your lab number 6. Okay, this is definitely okay, but I would say if you write something that's beyond 2-dimensional or 3-dimensional, make sure you know what you're doing. Okay. Okay. Any questions so far? Are we okay? Okay. Yes. Yes, yes. You want to rather than saying just create empty just array with all the initial value, you want to initialize to be some certain elements, right? Yeah. Yes, yes. Good question. The question was, is it possible to say in the case of the 1-dimensional array, we have this notation over here where we can just initialize at one go, right? We do have something like that. I'm going to show you right now. Okay. Let's say let me just use a new page over here. It's really important. Okay, let's try to say, let's say this is what I want conceptually. Let's say I want a 3 by 4 array. Let's say 3 rows over here. 1, 2, 3, 4. Okay, so now 0, 1, 2. So these are the row indices, and 0, 1, 2, 3. So these are the column indices. Let me just put some random values there. Okay, let's do that quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How do I do this? Apparently, one way to do it is by saying something like, you can just say, one way to do it, you can say integer array, whatever name it is, new, and 3 by 4. And then you can say, after that, okay, let's just show both ways very quickly. Okay, let me just review. Okay, approach 1. Okay, integer 2-dimensional array. Let's say A1 is new integer, and it's going to be 3 by 4. And what I should do is, for example, I can say A1 at position 0 and 0. So 0, 0 is talking about this particular slot. Okay, that's going to be assigned to 1, right? And then you're going to do this for 12 assignments, right? Okay, I'll leave that to you. That's one way to do it. Just do every slot. Another way to do it, which is like this. Approach 2. Okay, which is rather cool. So let's say, but I would say approach 2, be careful, the syntax is quite easy to get wrong. So I'll go over with you exactly how you can write it. So imagine that you're typing. when you say integer two-dimensional array, let's say A2 is assigned to, okay, I would say as soon as you do curly brackets, hit enter. You got that? And put a semicolon over here. So far, you have no syntax error, just empty, completely empty. Okay? Now, basically, remember it's going to be an array of arrays. So each element, you can see that in the case of the one-dimensional array, each element is simply just an integer. We don't really go further beyond the one dimension, the first dimension. But now, in the case of two-dimensional array, every element in the first dimension is another array. That's how we go further to the second dimension. So now how do we do that? Incredibly easy. So now, the first row is basically like here. Okay? So the first row, we can simply say array like that. I can say 1, 8, 5, 11. If you have only one row, that's it. If you have more than one rows, make sure you really put commas over here, like that. And then let's go for the second one. And then 6, 3, 9, 2. And also put a comma over here. And also you get 4, 10, 7, and 12. It's easy, right? Yeah. Okay. It's very straightforward. So you can think about in some way the syntax here is completely consistent with how you did it for one-dimensional array. Just make sure you know how to do it. If we apply this, remember we got this distance table over here. So now, how would you do it? Would you like to follow approach 1 or approach 2? Approach 2, right? Good, good. This is how you would do it. It's also in the source code, but I will show you very quickly over here. That's exactly how you do it. The only difference is over here, you can see that it's double type. Okay, I just put it double. Okay, and then you can see that we got comma to separate each row. Okay, so now let me give you a little bit test. What about that? Let's say that's the distances. Question for you. Distances 4 and 2. What's that? 1,000? Oh, are you sure? 1,549, right? Okay, let's try to do it together. Okay, be careful. 4 is going to be 0, 1, 2, 3, 4. It's going to be this row over here, and then column 2 is going to be 0, 1, 2. So here. Okay, this right here. Okay, similarly, let's say I want to change the value for particular cell. Let's say I want to change this. If I simply say print line, okay, this will give me this. So what about I say I want to change it? I can say distances, the same spot, 4 and 2. I want to reassign that to some other distance. Let's say, I don't know, 250, 2549. So what it will do is, it's going to change the contents for this one and override it to 2549. Okay, just like how you override the contents for one-dimensional array. Okay, now, having this in mind, how is this going to help us for the problem that we talked about in the beginning, right? Remember the distance table, the solution number 1, we got 49 if then else to program. Now with the one-dimensional array, it's incredibly powerful. Let's see that very quickly. Okay, so what we will do is, remember the itinerary we had before. We want to go from Boston and then to Chicago. Let me just remind myself. Boston, Chicago, Miami, Houston. Miami, and then Houston. Okay, that's what we want to have before. Okay, you know what? I think in this particular example which I had in the slide, I got a slightly different itinerary. Let's just follow that. Okay, let's just do another example here. Let's say this is my itinerary. I want to go from Miami to Boston, and then to New York, and then to Oh, that's it. That's it. Miami to Boston and Boston to New York. How is this possible? Actually, only two there. Sorry. I want it to be simple. Let's say that's my itinerary. Okay, that's it. Okay. Now, how can I do that? If I want to go from Miami to Boston and then Boston to New York. Okay, that's exactly what I meant to write. Miami to Boston and then Boston to New York and add it up together. So now you can see that to really calculate the distance from Miami to Boston, all I got to do is to figure out what's the indices for Miami and Boston. I can do that very easily, right? Imagine this. I'll give you some idea. Let's say if this is the trip array that we talk about. Okay, let me just draw it properly. Trip array, which points to an array of size 3. And then we got Miami is a string. And also we got Boston is a string. And also we got New York is a string. We cannot use these strings directly as indices for the two-dimensional array because they have to be numbers. It's very easy to get away from that. The way we do that is, as you can see from the source code, we can transform this array into another one. I can call that trip indices. And then over here, what I can do is, I will transform each city over here into the corresponding index, right? So now, I don't want to be wrong. So Miami is, if I can just refer to that very quickly. Miami is 4. And then Boston over here is 1. And New York is over here 2. Okay? That's what I can do. Right? You can imagine that I simply just run a for loop to go over every string over here and then simply assign the corresponding index into it. It's a little bit like assigning your numerical score to GPA or vice versa. Okay? That's what you can do. And after that, let's say we got this array over here. What can we do beyond that? How can we use this to access the two-dimensional array? I'll just finish this and then we are done. Okay? So now, let's say we are now running 0 and 1 and 2, right? Let's say the counter is I. Okay, I is starting from 0 over here. So that means we got trip instances, trip indices at position 0 is going to give us an index for the source city, right? And also, we also got trip indices at position 1, right? So we got this and this. That's going, let's say we got integer source, and also we got integer destination. So we got a 2 integer value over here, okay? So now how can we use them to refer to the two-dimensional array? We can now say distances, which is exactly what we said in the previous slide over here. We can now put source and then destination. As easy as that. Okay? So what I will leave to you by next Monday will be just go over the basic syntax for two-dimensional. We have covered them pretty much up to over here. Okay? But I'm going to release lab number 6 fairly soon. So I do encourage you to study a little bit ahead, especially to review the source code for the 2 versions over here. Review that. It's quite an interesting problem to solve using two-dimensional array. Okay, I'll stop here.